All right, this is the extra practice problems for Module 1. In case you felt like you needed some extra practice, this was that for you. And so let's go ahead and read the first one. It says, 2 students measure the mass of a kilogram standard known to be exactly 1,000 kilograms. The first student uses one scale and reports a mass of 1,002.0 grams. The second student uses a different scale and measures the mass as 1,000 grams. Which student is more precise? Which is more accurate? Well, the first student is more precise, and the reason is the first student's answer goes to the 10th place, and that's what gives it more precision. But the second student's answer isn't nearly as precise, but it's actually more accurate because that is actually 1 kilogram, isn't it? Its precision is to the thousandths place, though, but then it asks for the accuracy. So that one is more accurate. This one is more precise. Okay, number 2. How many centigrams are there in 403.1 grams? 403.1 grams, and we want to know how many centigrams. So we have 403.1 grams times line. Whatever unit is here has to go down here. And you're trying to get to the centigrams. I give the grams the 1. I know the book doesn't. That's just a choice that I make. I give the grams a 1, and that gives this the 100. Okay, so then this is going to cancel, and we will be left with 403.1 times 10 to the second, and then we would want to put that in proper scientific notation, so we would move this over to, so it'd be 4.031 times 10 to the 4th centigrams. Number 3, if an object has a volume of 1355.1 milliliters, we want to know its volume in liters. And I'm going to cheat here for speed's sake. We put the milliliters on the bottom and the liters on the top. I give the big one the 1, so this gets 1,000. You can do it the other way. If you give this a 1, you have to give this 10 to the negative third. One way or another, these two things have to be equal so that you're making a 1, a funky 1, remember. So then we multiply those, or actually you're going to take this number and divide by this, aren't you? So this is going to end up being 1.3551 liters. And you have 1, 2, 3, 4, 5 significant figures. 1, 2, 3, 4, 5 significant figures. This took it back 3 places, and so that would be your answer. How many inches are there in 26.2 miles? 26.2 miles, and we want to know how many inches. So we go times line, whatever's here goes down here, and our bridge in this case is going to be feet. So we know they're given to us how many feet there are into a mile, and then this has to go down here, and we know how many inches there are in a foot. We know in 1 foot there's 12 inches, and we know in 1 mile there's 5.2, that's an ugly 5, I'm sorry, 5.280 times 10 to the third feet. Now, I want you to notice this because I came up on the test with someone. They gave you this number in 4 significant figures. Therefore, you need to keep that in mind when you're figuring out your answer. This has 3 significant figures. This has 4. This has an infinite number of significant figures, so don't go there. They're considering the 12 inches to be an infinite number of significant figures, so we're going to have to count it this way. Our miles leave, our feet will leave, we'll be left with inches. So we're going to take this and we're going to go 26.2 times 5,280 times 12 equals, that's going to give me, it gives me a big number. I'm going to put it here so you can see it, 1660032 inches. But I'm limited to 3 significant figures here. This one has 4, that one has 3. I know that one has 2, but that's supposed to be an infinite number of significant figures, one of those. So we're going to limit this to 3 significant figures. So I'm going to go 1.66 times 10 to the 1, 2, 3, 4, 5, 6 times 10 to the 6th inches. Or you could have written it 1660000. I got enough zeros, and then gone like this. and put inches, that would still be in 3 significant figures, wouldn't it? But you had to have 3 significant figures in your answer for your answer to be correct. Let's see, number 5. How many kilometers are equal to that? Okay, so we have 5, 0, 7, 0, 0. Okay, and we want to know how many kilometers. Well, this is one. Remember, you always put whatever's here, here. And we're going to go to what they have in common, which is meters. So I'm going to put meters here, and then whatever's here has to go here, and now I can go to kilometers. Okay, I give the big guy the 1, so he gets a 1, this one gets 1,000. He gets the 1, this one gets 1,000. And so that's going to make this come back to 5.0007 times 10 to the, let's see, 1, 2, 3, 1, 2, 3. Actually, there's no times 10 to the. It's going to be that. This will cancel. This will cancel. We move that back. This has 1, 2, 3, 4, 5 significant figures. Remember, these 2 zeros are not to the right of the decimal at the end of the number, so they're not significant. These are between 2 significant figures, so they're significant. So I have to keep those. So that's why the answer would be 5.0007 kilometers. That's why. Okay, let's go to the next one. Let's see. Number 6, you have to be able to do something like this on your test. The volume of a box is given by the equation V equals length times width times height. If the box's measurement is 0.12 meters times 0.34 meters times 0.050 meters, what is its volume in liters? Okay, so first we take this, woo! And we don't kill our calculator because our calculator is our friend. Okay, so I've got 0.12 times 0.34 times 0.05 equals, we've got 2 significant figures, 2 significant figures, 2 significant figures. Remember, this is to the right of the decimal at the end of the number. And so this gives me 2.0, that's a 2, 2.0 times 10 to the negative third meters cubed. 0.12 times 0.34 times 0.05 equals, yep, get the same answer. And the answer that comes up in my calculator is this. I just want you to see it. Okay, that's the answer that comes up in my calculator. But I have to take that to 2 significant figures, which is there, and I'm putting it in scientific notation because it's easier to deal with. So it's 3 back. So there it is. Okay, so that's meters cubed. Now, I'm in meters cubed, and I go ahead and I want to get this to liters. And my bridge, if you remember correctly, is 1 centimeter cubed equals 1 milliliter. And that's where I can bridge meters to liters, right here. So I'm going to take this to centimeters cubed. So I'm going to go like this, and I'm going to put meters on the bottom because it's here, and centimeters on the top. I have to make this a 1 before I can cube the whole thing. So I'm going to go 1 here and 100 here. I can talk. 100 here, and then I'm going to cube the whole thing. So I'm going to go 10 to the 6 centimeters cubed, and then I'm going to go 1 meter cubed. That's my new one, isn't it? Okay. So now I can get from this number to centimeters cubed. So that's going to give me 2.0 times 10 to the third centimeters cubed. Okay? So far, so good. Now I know that 2.0 times 10 to the third centimeters cubed is equal to 2.0 times 10 to the third milliliters. And if you want it, you know what, I'm just going to show it to you just to be good, okay? So 2.0 times 10 to the third centimeters cubed times line. Centimeters cubed, milliliters, 1 to 1. So that gives us 2.0 times 10 to the third milliliters. And then from there, we can very easily go to liters because we just go like this, milliliters, liters, 1, 10 to the third. So it's going to give us 2.0 liters. And that would be our answer on that one. Number 7, a string measures 32 inches. How many centimeters is the string? 32.0 inches. We want to know how many centimeters. So we're going to go times line, inches on the bottom, centimeters on the top. This you don't have to memorize, it's given to you. Every 1 inch is 2.54 centimeters. We have 3 significant figures both places, so when we multiply it, we want our answer to be in 3 significant figures. What comes up in my calculator is 81.28 centimeters, but I can't keep that. I need 3 significant figures. So my answer is going to be 81.3 centimeters. I have to go to there. This is above a 5, or a 5 or above, so it's going to roll that up. And so this would be my answer. Let's do number 8. How many hours are there in 4,200 seconds? So we have 4,200 seconds. Now we want to know how many hours. Okay, so times line, we have seconds on the bottom, and I happen to know there's 3,600 seconds in an hour because I've done so many math problems with it. But you're not supposed to know that. So let's do it seconds to minutes, and then we'll go minutes to hours, because normal people, that would be the situation. Okay, not twisted, weird chemistry teachers. Okay, for every 60 seconds in 1 minute, and in 1 hour there's 60 minutes. There are 2 significant figures that we start with. These have an infinite number of significant figures, so we're not going by them. So our answer has to be in 2 significant figures. So we would go 4,200. And so my answer that comes out of my calculator is 1.166666667 hours. But I have to have 2 significant figures, so I'm going to make this 1.2 hours. And that would be the appropriate answer. Number 9, convert these numbers into scientific notation. This is important. Okay. We want to convert that into scientific notation. Now remember, there's 2 things you need to know for scientific notation. You need to make sure that you keep the number of significant figures. Which one are significant here? This one, and this one. These 2 are not between 2 significant figures, those 2 zeros, and they're not to the right of the decimal at the end of the number. Therefore, they are not significant. So when you take this to scientific notation, which your decimal is here, you're going to go 1, 2, 3, 4, but you're only going to keep 3 of these digits. 0, 8 times 10 to the 1, 2, 3, 4, and that would be that number in scientific notation. Let's do the next one, 0.007840. Now, you're going to put it in scientific notation. You're going to go 1, 2, 3, because remember we have to have 1 non-zero digit to the left of the decimal. So we've done that here. And then you only keep significant figures. So this 0 is to the right of the decimal at the end of the number. So we would keep it. So we would have 7.840 times 10 to the negative 3rd. And that's how you would put that into proper scientific notation. Then on number 10, it says convert these numbers into decimal notation. So we have 9.510 times 10 to the negative 14th. Remember, all of these are significant figures. We've got to go 14 times back that way. That's what they want. So in other words, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That would be converting it back because it's 14, and so I had to take it to there. So I have 13 zeros and 1. 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13. Yep, there you go. That would be that answer. The next one is 9.0050 times 10 to the 6th. So we're going to go 6 that way. 9, 1, 2, 3, 3, 4, 5, 6. Now, so we're going 1, 2, 3, 4, 5, 6. So we go 2 past that. 1, 2. Okay. All right. So that's taking it back into decimal notation. But here we have 1, 2, 3, 4, 5 significant figures. And here we only have 4 significant figures. And what the book says, notice how the decimal notation does not differentiate between a 0 that is measured, the 0 in the hundreds place, from a zero that is rounded, the last two zeros. So in other words, we can't help the fact that the significant figures are off. Just wanted to point that out. Okay. Okay, number 11. How many significant figures are there in these numbers? And this is very important to be able to do. So A, 7, 3, 5, 0. These zeros are not between two significant figures, so they don't count. They're not to the right of the decimal at the end of the number. They are to the right of the decimal, not at the end of the number. This one is. So there's 1, 2, 3, 4 significant figures there. If we do 7, 3, 5, 0, this 0 is not between two significant figures, and it's not to the right of the decimal at the end of the number. And so here you only have 3 significant figures. And then 7.005 times 10 to the 4th. This makes it easy. All 4 of those are significant figures. That's why they're written there. Whatever's written in scientific notation, that they are significant figures. So you're in good shape. Okay? And then number 12, convert 34.5 degrees Celsius, and we want to go to Fahrenheit. Fahrenheit equals 9/5 degrees Celsius plus 32. So we're just going to put in here 34.5 degrees Celsius. I'm running out of room here, aren't I? Plus, there we go. And so in your calculator, order of operations, you're going to go 34.5 times 9 equals, divided by 5 equals, plus 32 equals. Okay, what comes out of my calculator is 94.1, and this should be degrees Fahrenheit, but we started with 3 significant figures, so we're going to end. So that would be the answer. It would be 3 significant figures. So in that case, we're in good shape. Let's do the next one. 350 degrees Fahrenheit, and we want to know what that'll be in Kelvin. Okay, so first we need to take this to Celsius. And so to do that, we know that degrees Celsius equals 5/9 degrees Fahrenheit minus 32. And this parentheses are important here because it's got to do with the order of operations. So we're going to put our 350 into that parentheses. 350, 0 degrees Fahrenheit minus 32. There we go. So we're going to go 350 minus 32 equals, times 5 equals, divided by 9 equals. And we have 4 significant figures. So what's in my calculator is 176.666666667. So to go to 4 significant figures, I'm just going to go to 7 here. This is degrees Celsius. Okay. And then we know that Kelvin is 176, this is my Celsius, degrees Celsius, plus 273.15 is going to give me my answer in Kelvin. And so I'm going to go 176.7 plus 273.15 equals, what comes out in my calculator is 449.85, and that should be Kelvin, but we are adding and subtracting. This goes to the 10th place. This goes to the 100th place. So my answer has to be to the 10th place. So my answer actually has to be 449.9 Kelvin. You can't take it out to there. Okay? So your answer would have to be there because of significant figures. I hope this helped. So go ahead and study this as best you can. Don't worry if you don't get all the significant figure stuff right now. You're going to be using it throughout chemistry. It's hard. It takes time. You'll get it eventually, so don't even worry about it. Just keep working on it. And go ahead and take your test and read the first half of the next chapter. Have a Jesus-filled week.